Hi Year 9, welcome to your weekly introduction videos. We're going to be looking at the idea of speed, distance and time. So there's three main things we need to understand. We need to understand and remember the formulas that link speed, distance and time. We need to be able to convert between different units of speed. Where we measure speed in meters per second or kilometers per hour would be normal. I mean, there are other ways of measuring speed, but those would be the normal ones, meters per second. Sometimes we just write it like this, meters per second, and then kilometers per hour as well might be another way of measuring speed, okay? The same way you might measure distance in centimeters or meters. It really depends what you're looking at, okay? And then finally, we need to understand speed, distance and time when the information is presented on a graph. Okay, now, what is speed? Well, speed is a measure of how far you travel in a certain time. Okay, you think about it. If you go fast, you travel more distance in the same amount of time. Okay, if you're going slow, you cover less distance in a certain amount of time. So that means speed is equal to distance divided by time. Okay, so that's what I always start with. I always just remember that formula. That's really, really, really important. And as long as I know that formula, what I can do now is I can rearrange things. So I'm just going to write it like this: speed equals distance over time. And you know from solving equations that, for example, what I can do is I can multiply both sides of this equation by t. Well, if I do that, I end up with distance equals speed times time. Okay, multiply by t on both sides. So that's another formula. Distance equals speed times time. And then what I can also do is I can, both sides of the equation, I can divide by speed. And if I do that, I will end up with time equals distance over speed. Okay? So that's another formula. Time equals distance over speed. It's actually one formula, but it's just rearranged. So we can rearrange it, depends on what information we have and what information we want to find out, depends on which of the three formulas we will use. So I would expect that in your notes you would write down these three formulas, okay? I don't think you guys are always very good at getting your books out and doing things in the right way as if it was normal school, okay? Get your books out, do all your work and paper, make good notes, okay? Now there's another little way of remembering this. You can do a little triangle, okay, and it looks like this. I mean, you might have learnt this in science class. And in there we're going to do speed equals distance over time. Okay, and so that's the one I always have to remember. Speed equals distance over time. Now if I put my finger over distance, I can therefore see that distance equals speed times time. And if I put my finger over time, I can see that time is equal to distance over speed. So that little triangle can help me remember all three formulas. Okay. Right, so here's a few questions. Now, Sebastian covers 240 miles in 3 hours on a highway. That's a very, very easy question. All you've got to decide is what you're actually trying to work out. Remember the simplicity of maths. What's the correct formula? What do you know? Put in what you know and put X, maybe if you need to, where you don't know, okay? So we're trying to work out speed here. Well, speed equals distance over time. So speed, I don't know that, so I'll keep it as S, is equal to distance. Sebastian covers 240 miles. That's his distance in 3 hours. Okay, so the speed is 80. Now, what's really, really important when you're dealing with speed, distance and time is the units. The units are so important. Okay, and what we're doing is we're doing miles per hour. So mph, miles per hour. We're traveling at a speed of 80 miles per hour. Okay, you must use according to the distance and the time units that you've used. Okay, that's really, really important. Okay, normally you'll be working in kilometers per hour, but these questions are about miles. Now, Jess cycles to work at an average speed of 16 miles per hour for 45 minutes. What distance does she cover? Now, this is where people start to get things wrong, okay? Now, first things first, what we want to know is distance. Well, distance equals speed times time. So that's the correct formula. There it is. Distance equals speed times time. Now, and here is the mistake that people will make, okay? We don't know distance, so keep that as D. She goes at a speed of 16 and a time of 45 minutes. So let's just put that in there. Let's just work out a calculator. Let's do 16 times 45. 720. Now, 720 what? Well, it's 16 miles per hour. So she's gone 720 miles in 45 minutes. Really, do we think that that is realistic? Jess is going to travel 720 miles. That's about the same distance as here to Salalah. And she does that in 45 minutes on a bike. That's obviously wrong. Okay? Now, what is it that we've done wrong? Well, just go back here. We've used the right formula. Distance equals speed times time. What we've done wrong is we've mixed up units. This one is miles per hour, and the time is in minutes. So we're mixing hours with minutes, which we cannot do. So the easiest thing to do is change 45 minutes to an amount of hours. So 45 minutes. We need to say how many hours that is. Well, the easiest way to do that is say 45, there's 60 minutes in an hour. So what we've got is 45 out of 60 minutes would be how many hours. So if you divide your number of minutes by 60 minutes per hour, it will tell you what you're going to get in terms of hours. So 45 divided by 60 is 0.75. So 45 minutes is the same as 0.75 hours. You know, I know that fraction, 45 over 60, can be simplified to 3 over 4, which is 0.75. If you don't know, use a calculator, okay? But you should know, frankly. So instead of using 45 minutes, we're going to use 0.75 hours because, oops, that's 16 miles per hour. So we're going to do 16 times 0.75. Okay, 16 times 0.75 equals 12. And so the distance is 12 miles. Okay, and that is much more realistic, that you might cycle 12 miles to get to work. Okay? So, you know, a lot of these questions you can check through common sense. You know, it's not realistic to travel 720 miles to work, especially on a bike. Okay, right, part C. A mapping app suggests that the average speed on a busy road is 22 miles per hour. How long will it take to cover 5 miles on this road? So how long will it take? What is it you're being asked to find out? You're being asked to find out time. Time is equal to distance over speed. Just use the right formula. So time is equal to the distance is 5. Okay. And the speed appears to be 22. And I have no issue with these numbers because this is 5 miles. And this is miles per hour. So we're not mixing up any units. So I can just go straight to my calculator. 5 divided by 22 equals, it's quite a nasty number actually. T is equal to 0.227, I think that's recurring actually. 227, it's like that. It's going to be like 0.227, 227, 227. And that, what's the unit of measure? Well, that is hours. Now that's a really sort of horrible number. So what I would look to do is convert that back into minutes. Okay, what is 0.227 recurring hours? So I'll go the other way this time. I'm going to times this by 60. So I'm going to do 0.227 recurring times 60. So multiply my answer by 60. And I'm going to get about 13.63 minutes. Okay, 13.63 minutes. Now, that's good. That's much better. That gives me more of a sense of how long the journey is going to take. But I can do even better, actually, because 13.63 minutes is sort of a nastier number of minutes. What I'm going to do is I'm going to change that 0.63. I know I'm going to do 13 minutes, so let's just write that down there. I know it's going to be 13 minutes, but then it's plus a 0.63 of a minute. Well, why don't I convert that into seconds? Which I can do by, well, how many seconds are there in a minute? Well, there's 60 seconds in a minute. So if I times that by 60 as well, so just use my calculator, then I will get about 38.2 seconds. And I'll just simply round that to the nearest number of seconds. So I'm going to say the journey will take 13 minutes and 38 seconds. Now that is a length of time that you understand really well. You understand minutes and seconds. What we don't really want to be doing is writing down decimal numbers of minutes and decimal numbers of seconds. We convert them, okay? So that journey is going to take 13 minutes and 38 seconds. So I would expect you to be able to take, what we've actually done there is we've taken 0.227 recurring hours and we've turned that into an appropriate number of minutes and seconds. Okay, I would expect you to be able to do that now. Okay, right, let's just do a little check of the formulas. Let's have a look at this. Stop your video and tell me if you can see which of the formulas is correct and which are wrong. Okay, this one's definitely wrong because speed equals distance over time. This one is wrong because time equals, no, that one's not wrong, is it? That is the correct one. Time equals distance over speed. So that can't be right because time equals distance over speed. And this one, distance equals speed times time. So actually the only one that was correct was this one here. Okay, so you've got to know those formulas. All right, no good if I ask you in a couple of weeks' time, say, I can't remember the formulas. You have to remember them. Okay. A car travelled at 150 kilometres in 3 hours. What was its average speed? Okay, that should be easy. Speed equals distance over time. 150 is the distance over 3 hours. It's 50 kilometres per hour. The answer is C. Okay. What about this one? Stop your video and have a go. Okay, a jogger travels at 5 meters per second for 30 seconds. How far does it travel? Right, how far does it travel implies that you're trying to find out distance. Distance equals speed times time. Now, if you do this, 5 times 30, you will be wrong. 5 times 30 equals 150. And you'd think that would be meters, so you'd think the answer would be B, but you would be wrong, okay? Because you're mixing. No, you wouldn't be wrong at all. You wouldn't be wrong talking absolute nonsense. I didn't read the question properly. That would be the right answer because you're not mixing units. you're not mixing units. This is seconds and this is meters per second. So the answer is going to be 150 meters. So it's absolutely the correct answer. So I was thinking that this was, you know, maybe kilometers per hour or something like that. So I didn't read the question properly. Make sure you do that. Okay, now here is where you'll be wrong. A cyclist travels 6 kilometers at a steady speed of 12 meters per second. How much time does this take? So we're looking for time. Time equals distance over speed. So if you do this, time is equal to 6 over 12. Time equals what? 0.5 seconds? I really doubt that. I doubt that you can travel 6 kilometers in half a second unless you're in a rocket ship. You certainly can't cycle that fast. Not even the world's best Olympic athletes can do that. So why is it wrong? Because you're mixing units. 12 meters per second, 6 kilometers. We cannot mix up the units. So let's start again. Time equals distance over speed. Well, the easiest way to get the units unmixed is to change the kilometers into meters. 6 kilometers is equal to 6,000 meters. So if we say that the distance is 6,000, okay, and we divide by the speed, which is 12, we're not mixing up any units because it's meters and meters per second. So we're going to do 6,000 divided by 12, which is 500, and the units are going to have to be seconds. So the answer is 500 seconds. Now, what I would like to do is, you know, we can change that to minutes. And all I've got to do, if I want to change that to minutes, I'll divide it by 60. So if I do 500 divided by 60, okay, then I get 8.3 recurring minutes, which is not really what I want. It's 8 minutes, and let's turn that 0.3 recurring into seconds. So 0.3 recurring times 60, because there's 60 seconds in a minute, is 20. So it's 8 minutes and 20 seconds. Okay, so I've changed that 500 seconds into minutes and seconds. Okay, I'd expect you to be able to do that. Right, I'm going to stop the video there before it gets